We now talk about principle of superposition for electric flux. So say you have a surface and you have a charge inside it. So this charge is say Q1. So the net flux by Gauss's law is given as Q1 over E0. So consider another surface. Now you have three charges inside it, Q1, Q2 and Q3. So first make charge Q up, which is sum of Q1, Q2 and Q3. So the flux is Q over E0. So you take the sum of the charges and you divide it by E0, you get the flux. Now say the surface has two charges inside, Q1 and Q2, and there is a charge Q3 which is outside the surface. In this case, you write total charge Q as Q1 plus Q2 and the flux is Q over E0. So notice that we are ignoring the charge Q3 which is outside the body. So it is only the charges inside the body which will contribute to flux. The formula for flux is given as surface integral of E vector dot product with ds vector. Now this electric field might be the sum of electric fields. As we have just seen, if there is two or more charges, they have their separate electric fields. So the flux would be sum of these electric fields instead of E. So we are just trying to justify the formulas which we have written on the left hand side. Times ds vector. Now the idea is that you can add individual flux. So this integral will split up into individual fluxes and each individual flux comes because of its own charge. So basically you can add up all the charges. So the flux would be Q over E0, where Q is the total number of charges. And this Q comes because you can add up the electric fields with each other. And the electric fields you can add with each other because you can add the charges up. So Q is the total charge inside the surface.